Hello math lovers, welcome to the channel. In this video I have a geometry question with me, but before I go to the question, today I am going to ask you a GK question, the answer to which I will give at the end of this video. So the GK question is that yesterday on 15th of July 2023, India launched a moon mission called Chandrayaan-3 mission. Most probably on the 23rd or on 24th of August 2023, this mission will land a rover on the south pole of moon. Your question is, what is the cost of this mission? Is it A, $300 million, B, $500 million, C, $75 million, or D, $1 billion? The answer coming up at the end of the video. Now let's move to our maths question. The question is that we have three identical rectangles R1, R2 and R3. So from R1 we cut out the largest possible quarter circle Q, from R2 we cut out the largest possible semicircle S, and from R3 we cut out the largest possible circle C. So we have got three questions from this statement. So question number 1 is that if the ratio of the length and breadth of each rectangle is 9:8, then what is the ratio of the areas of C and S? Question number 2, if the ratio of the areas of the quarter circle Q and the semicircle S is 8:9, then what is the ratio of the length and the breadth of each rectangle? And question number 3, if the area of C is equal to the area of S, then what is the ratio of the length and breadth of each rectangle? Now let's move to our answer one by one. Now suppose that this is our rectangle R1 and R3, from which we cut out the largest possible quarter circle and the largest possible circle. So let the length of this rectangle be L and the breadth of this rectangle be B. If we cut out a quarter circle from this rectangle R1, then the radius of this quarter circle will be B, because we are cutting it like this, taking this vertex as the center of this quarter circle. So we have radius as B. Now the area of this quarter circle will be pi b square over 4. This is because the area of a circle is pi r square, and we have r, that is radius, equals to B. So we have pi b square, and this area, that is the area of the quarter circle, is 1/4 of the circle. So we have to divide this formula by 4. So the area of Q is 1/4 over pi b square. Now similarly, if from R3 we cut out a circle, then the radius of this circle will be half of this breadth. So our radius R will be B half. The area of this circle will be pi b half square, and that will be equal to 1/4 pi b square. We note that the area of Q and the area of C is the same. That is, the area within this quarter circle and the area within this circle is the same. And now we move to the largest possible semicircle cut out from the rectangle R2. So we have got three possibilities. The three possibilities are when length is bigger than 2 times breadth, or when length is equals to 2 times breadth, or when length is smaller than 2 times breadth. So when the length is bigger than 2 times breadth, then we see that its radius will be equal to breadth. Here you can see that the length is very big. So we take this radius equals to B. We draw a semicircle like this. Now if length is equals to 2 times B, then you can see that its radius equals to B, or its radius equals to L half. In the middle of this length we take the center, then we can draw a semicircle like this. So L becomes the diameter and B becomes the radius of this semicircle. Now if the length is smaller than 2 times B, then we cannot draw a semicircle having radius equals to B. If we draw a radius equals to B, then that will not be a proper semicircle. So we have to take the diameter of this semicircle equal to L. So its radius will be L half. We take a point in the middle of this length, and that becomes the center of the semicircle, and we draw a semicircle. So we have got three possibilities in cutting out the largest possible semicircle from any rectangle. Now we move to our question number 1. The ratio of length and breadth is given as 9:8, and the ratio of the areas of C and S is required. So the area of C, as we have seen, is 1/4 pi b square. Then we have to divide this by the area of S. Now to find out the area of S, we need to know its radius. So we see that the length is smaller than 2 times breadth, that is 9 is smaller than 16. So this is the third case in which radius was L half. So we take radius as L half. So area of S will be pi L half square over 2. We take over 2 because the area of semicircle is half of the area of circle. Now if we solve this, then we get 128 by 81, which is our answer. Now question number 2. So in question number 2, the ratio of the area of Q over area of S is given as 8:9. That is this area, that is the area of the largest possible quarter circle, to the area of this largest possible semicircle is given as 8:9. Now we have area of Q as pi b square over 4, and the area of S is pi L half square over 2. So we are using L because we need to find out the ratio of breadth and length in this question. So if we have breadth in the area of Q, then we have to take L in the area of S. Otherwise, if we take B here, then BB will be cancelled and we will not get any result. So now if we solve this, then we are going to get B over L equals to 2/3. So our ratio of breadth and length of this rectangle is 2:3. That means if breadth is 2, then the length will be 3. So now we move to question number 3. So in question number 3, it is given that the area of C equals to area of S. So you see that area of C, that means this area that is formed when we cut the largest possible circle from the rectangle, is equal to this area when we cut the largest possible semicircle from this rectangle. If this area of the circle is equal to this area of the semicircle, then our question is, what is the ratio of the length and breadth of this rectangle? So we take the area of circle as pi b square over 4, and we take the area of S as pi L half square over 2. Now if we solve this, we are going to get L over B equals to √2 over 1. The ratio of length and breadth of this rectangle is √2 over 1. That means if breadth equals to 1, then length will definitely be √2. Now friends, I have an additional question for you. The question is, the area of S is not less than the area of Q. True or false? Since the area of S is involved in this question, so you remember it that when we tried to cut out the largest possible semicircle from the rectangle, then there were 3 possibilities. So if you try to solve this question with the first and second possibility, then this statement will definitely be true. So let's try to solve it with that third possibility, in which the length was smaller than 2 times breadth. So here in this question, it is given that the area of S is not less than the area of Q. That means the area of S is greater than or equal to the area of Q. So let's represent it and see if it is true or not. So the area of S, according to that third possibility, is pi L half square over 2, and the area of Q will be pi b square over 4. Now if we try to simplify this area of S, then we get L over √2, and if we try to simplify the area of Q, then we get it equal to B. So we have area of S as L over √2 greater than equal to the area of Q, which is equal to B. Now if we take B as 1, then L will become smaller than 2. This is because we are taking third possibility where the length is smaller than 2 times B. Now if B is 1, then 2 into 1 is 2, so length will be smaller than 2, so this L is smaller than 2. Now if we keep smaller than 2 here, then smaller than 2 over √2 will be smaller than √2. So smaller than √2 is greater than or equal to 1. Now what do we mean by smaller than √2? So smaller than √2 can be any infinitesimally small number but greater than 0. So we have two possibilities here. The range in which this number is infinitesimally smaller to just under 1, this statement will be false, and for the range in which this number will be 1 to just smaller than root 2, this statement will be true. So our answer to this question will be the area of S is not less than the area of Q can be both true and false. It depends on the length and breadth of the rectangle. Now friends, I answer you the GK question that I asked you at the beginning of this video. The cost of moon mission Chandrayaan 3 is $75 million. That is option C. So $75 million is like $75 million is like the budget of producing a movie. ISRO, that is Indian Space Research Organization, is becoming famous for cheap satellite launches nowadays. I congratulate ISRO. What you people think? You can comment me in the comment box. Thank you.